Yeah.
Right.
So now you can start your screen share and you can start the presentation so that we can discuss more later soon.
Okie dokie. I will share my screen, get my PowerPoint up. Yeah, basically, excellent. You can see everything now. So, yeah, my name is Robert Laird, as Javier said. Thank you very much for organising another one of these good events. So I'll be talking about, as I say, creating a better world with biochar, and I'll just give you a quick rundown. Carbon offset zone, we offset carbon footprints and for voluntary and compliance markets. We also have technologies. My history for over 10 years is in biochar and technology. So that's what this presentation is all about. So this is fighting global warming with fire. The carbon cycle we'll start with. Just, I know some of you already know about it, but just to make sure everybody's on the same page. Carbon present in the atmosphere is absorbed by plants during photosynthesis, and some of these plants are then consumed by animals, and the carbon gets assimilated into their bodies. When these animals and plants die, carbon is released back into the atmosphere during the decomposition. That's the normal natural cycle, and that's carbon neutral. Some of the carbon that's not released back into the atmosphere eventually becomes stored as fossil fuel. If these fossil fuels are then burned for man-made activities, they release more carbon back into the atmosphere, causing the greenhouse effect, which is carbon positive, which we know as global warming. The biochar cycle, on the other hand, the same plants and animals can die, but if they're pyrolyzed in a unit like ours, then 50% of the carbon is captured, stored for a long time. And this helps reduce the atmospheric carbon in the atmosphere. This is carbon negative. Some of the other products apart from the biochar, syngas and bio-oil, wood vinegar, we use all of those products, which is better than releasing them back into the atmosphere. So overall, there's a net reduction in atmospheric CO2. Pyrolysis, again, some of you already know everything about this, but just talking to the masses, pyrolysis is the thermal decomposition of biomass in the absence of oxygen. The flammable gases that are released are then cooled and reintroduced into the firebox, and that drives the process. The liquid fraction is also collected and used later. We use it as a pest deterrent, a biostimulant, an accelerant. There's many uses. What remains is biochar, which is mostly carbon. That is carbon negative. This is a little graphic showing a tree. It draws down carbon from the atmosphere. We put it into the machine. We capture the liquids. We use the flammable components to drive the process. So no fossil fuels are used, no electricity is used, not even a battery. So it's just using the waste to drive itself. This creates biochar, which is a stable form of carbon. And then we return that back into the ground. This grows more plants, sucking down more carbon from the atmosphere, and so the cycle continues. A lot of people who already know about biochar, in the literature, it all talks about 7,000 years of storage capacity, at least. Being Australian, I know better because we have the oldest living culture in the world in Australia. The Aborigines, that culture is 70,000 years old, and their cooking sites where they've caught fish, they cook it next to the river with a fire. So there's man-made charcoal left. That charcoal ends up over time buried in the ground, and scientists, geologists, and archaeologists, anthropologists. They've all studied Australian soils and found these, what they're called middens, where the Aboriginal people have been cooking on, and there's carbon found in the ground that dates back 70,000 years in this country, and that's man-made charcoal. So that's a game changer for the biochar industry. Let's not bother talking about 7,000 years, that's nothing. 70,000 years can be proven. So this is going to be a little short video, which will tell you a little bit more about what we do. It'll show some of the machines that I've designed, and they're being sold and built all over the world. There's one running somewhere in the world at all times. And here we go. You can ask questions at the end.
Yeah, thank you, Robert. Thank you for your quick presentation. Is it finished?
No.
Biochar release.
So now there's a picture of biochar under an electron microscope. This is grapefruit, just a branch from grapefruit tree. And as you can see, it's peppered with lots of tiny little holes that not only draw water in, but also hold microbes. They house microbes, and the microbes multiply when they're happy. They move in, and every 24 hours, there's 10 times as many as there was the day before. The microbes themselves help move nutrients around, which, when it's around the roots, makes the soil around the roots much more fertile. Mycorrhizal fungi also grows through biochar, which also helps transport nutrients to the plants. Certainly, when used with wood vinegar, this is a picture of a couple of different samples that I've collected in my unit. Some of them are just mixed species, some of them are specific to one species at a time. One of those is even municipal solid waste, done pallets, that sort of thing. So you can use anything. I've done animal bones as well. It all makes charcoal. If it was ever alive, it'll become charcoal. Wood vinegar is almost unknown in the Western world, but it's a fantastic product with hundreds of potential uses. One of the exciting things for me is it brings down the cluster value of water, which means it makes the water runnier. So where it would normally have a ball of water sitting that can't penetrate a small hole, with the addition of a tiny little bit of wood vinegar, it will run a lot easier and be drawn up by the plants much more effectively, making the effectiveness of the fertilizer even better. So you need less fertilizer if you're using wood vinegar as well. So that's an exciting move. It's also being used in animal husbandry in place of antibiotics. It's an organic product, and that's better for human health. If the animal ends up being consumed by humans, we don't have to take on those antibiotics, weakening our own immune systems. It also goes a very long way. It's usually diluted approximately 200 to 1 with water, even up to 500 to 1 in some applications. So it's a magic product in itself, and it's certainly worth collecting. So that's it for my slideshow. We've got a bit of time, I believe, so I'm happy to answer any questions anybody else has, and I'm happy to talk.
Yeah, thank you, Mr. Robert Laird. So, is there any questions on this presentation? Robert Laird gave his presentation about his mobile pyrolysis units and his products like wood vinegar, biochar, and other. So, is there any questions or any inquiries about this? He's happy to answer if any questions.
If you come up with a question later, you can always contact Carbon Offset Zone. I'm happy to answer any questions. That's fine.
Yeah, 2 more presentations are there so that we can discuss about this later. So our next presenter will be wait a minute. Marcel Huber, are you there? Syncraft. Okay, we can now go with Dr. Richard Cropp's presentation, and then as per the schedule, Marcel Huber will give upcoming presentation. Hi, Dr. Cropp.
Yes, Yes, hello and hi, and sorry I couldn't answer any questions just now because I was rushing from one meeting where I just gave this presentation I'm giving yet right now in the Marriott to some ministers in the Malaysian government. So I just had to rush back from there. So I'm now giving the presentation a second time today. Okay, so do you want me to start?
Yeah, okay. Will you give next presentation?
Come again?
Will you start your screen share and will you start your presentation now?
Okay, share the screen.
Yeah, sure. Thank you.
Hey, open system references, blah, blah, whatever. Okay, can you see the title? Hello? I can't hear anything.
I can't see anything.
Me neither.
I'm
Just,
also not sure. It shows on my. I press share screen again. Oh, Microsoft PowerPoint. Okay, let's press that one.
No screen is there.
No, we cannot see your screen.
Yeah. Yeah, Zoom has changed something, so I'm a bit. My presentation is open, but it doesn't want to share. Let me try one more time.
In the bottom, there is a share screen in the green color.
Yes, I press that, and then comes a panel which says desktop whiteboard.
Yeah, there it should come.
Put desktop 1 again. Doesn't want to do anything there.
Is it showing anything like any message or?
Open system preferences. What have to do?
If you press share screen, then you have a different screens normally showing up. You have to double click on one. You have to select one, and then normally it should share.
Yeah, it did that, and now it put me to system preferences and it asked me to add Zoom US app as a.
Okay. Mr. Marcel Huber started his screen share. Dr. Cropp, Dr.
We
Cropp.
can see now.
Sorry, it was just a trial from my side. Sorry.
Yeah, it's okay. So can you see now?
No, not
Not
yet.
now again.
Any screen to be seen by your side other than my face?
Nothing.
No,
One second.
Maybe you need to restart.
okay, then
If
Dr. Cropp,
you want,
can give next presentation.
yeah. If you want, I can jump in. Yeah.
Okay. Yeah, now it looks like.
Oh,
Yeah.
Yes, now okay.
Now you can see, okay. Okay, can you see now?
Yeah, we can see now.
Okay, I had this presentation today as well in the Marriott for some ministers and other people of the industry, talking about decentralization of biofuel and char. Now, the decentralization is there because the minister also mentioned the transportation cost of all the biomass materials is what kills the business. And we know that because we have been looking into this quite some time. And together with the university, we have developed a catalytic depolymerization to convert the biomass into biofuel, liquid and gas, as well as char as a solid product. Now, catalytic is required in order to keep the capital expenditure low and also make the plant smaller. Now, when you make the plant smaller, you can decentralize it because you don't have to move this very far away from the biomass. You can put it in the neighborhood, and therefore the transport cost will be minimized. Now, we call this a threefold catalytic plastic biomass to oil approach because reducing the transportation cost is paramount for the future of profitability. Lowering CapEx is necessary to make it more adaptable so that it can be multiplied much faster than if you have to look at the large investments of 50 to 100 million. And the third part of this presentation is we are getting gas and oil and char, but these products have a value that can be maximized, and it's required to do so in order to have the profitability at hand. So what we do is we start with shredding and separation, wet and dry. The reason for that is many approaches, they have wet biomass and need to get rid of the moisture. Now, this is normally expensive because you have to spend energy and that reduces your operating profit. So what we do is when we do the shredding, we are squeezing the biomass to remove all the wet mass. It becomes like a slurry, and we send that to an anaerobic digester. The reason for that is anaerobic digesters work wet, so you don't have to remove the water. Now, for the solid part, which can be plastic, frankly, actually, solid green biomass is natural plastic. We have added the artificial plastic to it, but the CC bonding is still the same. For that solid part that doesn't have much water, we use a catalytic conversion to make oil and biochar out of it. It has to be catalytic in order to keep temperatures low, which makes the equipment cheaper. Also, the amount of oil and gas is higher, especially with a fraction of oil being more preferential, so that you have to get more energy that you can sell. And third, now we have gas and oil which we can sell, but in the end, the finished product is the energy you create out of it. And for that, we have developed a new type of engine that can do 30 to 50% higher conversion rate of any fuel into electrical or motion energy. Now, I show you some samples of what we have done so far. What you see here is a biomass digester. This is done together with a stem-owned company called Aramco here in Malaysia. Is a containerized or container-sized unit. What you cannot see from outside is that it is not a simple tank as most biodigesters are. This one here has an internal structure which is similar to a blood cell. The reason for that is because the different bacteria to do anaerobic digestion, they require slightly different environments. And in order to achieve that, a plug flow system is better because you can have a liquid with different concentration at the beginning, at the end, and you can refurbish the gas from one section to another section in order to maximize bacteria growth. That way, you reduce the residence time. That means that you don't have to wait so long for the material to be all digested. And that obviously saves space and capex. Now, what you see in front there is our shredder and conveyor to put in the biomass. And in the corner there, you see the blades that we are using. This is just an example of how we innovate. The blades there are designed to minimize plastic entanglement. So normal shredders, they have plastic bags all getting pulled up around the shaft, and then you have to stop and remove all the blades. In our case, we have blades that do a cutting process, so the plastic gets cut and removes itself. Secondly, you can see these blades are not full circles. Why? Because with this construction, we can actually take out the blades and sharpen them without removing the shaft. So we are saving a lot of manpower and man hours in order to service our shredder. It's the first shredder of this type in the world, actually, and it's commissioned for Alam Flora here in Malaysia. Now, in this slide, you see the machine that we are using to convert the biomass or the plastic into oil. You see a screw press here in the center with two input hoppers. The first input hopper is for the biomass or the plastic or both together with all the water. Now, when the screw is running, it squeezes this material and reduces the volume drastically by factor 10. At the same time, it removes the water so that it can be pressed out like a slurry and be transferred to the anaerobic digester. But most importantly, it also seals the material towards the final reactor so that no air can go in. This is a big issue in many pyrolysis plants. They have air and then they create a combustion. Combustion is also called in Germany hot renovation because you have to build a new plant. Anyway, so what we do is we are forming a plug that seals off the air. We compress all the solids, and the screw itself, together with outside heating, creates heat inside the material that exceeds 300 degrees. Therefore, we have a second hopper seen here, where we add catalyst. So when the water has been removed and the catalyst is mixed into the material, it starts cutting the carbon chains to make oil and gas. Now, for biomass, we get typically 20 to 30% oil. This catalyst that we developed is also able to do empty fruit punch, which is a very easily available biomass in Malaysia because of all the palm oil mills. And this particular biomass has high lignin content, which normally does not allow it to be easily digested. So for this particular catalyst, we have achieved up to 30% conversion rate with empty fruit punch. Now you may ask, what about the plastic? And it may surprise you, but plastic is way easier to cut into smaller pieces with the catalyst than you can do that with biomass. So for plastic, we have a conversion rate between 60 to 80%. So down here, you see the team from the university. And on the next slide, you see actually the machines that are currently in operation. The first machine, where you saw the bucket, had rice husk inside. This machine is also a screw, and it uses the rice husk to convert it into a catalyst. So we are actually also making the catalyst from a renewable resource. So when you look what is coming out there in the bucket, this white powder is the base, the bulk base of the catalyst we are using. and it is made purely from rice husk. The design of the equipment also is done by us. The work on this started about 15 years ago. So this is actually the third version of the machine, which is much larger because we are slowly going into commercial production of the catalyst, so that we also can have enough catalyst to make enough oil. The second video where you see a similar machine is the screw press that makes the oil. So here you see some steam and wood vinegar coming out. The oil is collected down here. And with this equipment, we have verified the amount of oil we can get from empty food bunch. Now, at this point in time, we have oil and gas. But you can't do much with oil and gas. You need to combust it in order to either create heat or motion or electric energy. Electric is now very popular because everybody talks about electric cars, but not all the energy will come from solar and wind. There is a large amount of waste that need to be additionally made into energy in order to sustain the energy demand that we currently have. And because of this, we have been looking into engines for since more than 10 years. I had my first talk about engines with Mercedes research leader, Dr. Hart, like 7 years ago, and we offered him to do a cylinder head with only one valve, not 5 like Yamaha has. And he said, Dr. Cropp, I can't buy this from you because the last time we bought something like this, we bought the Wankel from NSU and we couldn't get it working. So we sold it to Mazda. So I said, okay, let me think about it again. And I was looking into why the Wankel wasn't really successful. And this is how, in the end, we came up with a new engine concept. Now, I won't disclose here to you how the engine actually looks like. This has to do with patenting and with trade secrets. You will see it early enough when it's in your hands or in your next car. It may take another year or so, but what is important is we have designed this engine to create more power output from the same amount of biomass than before. We are estimating 30 to 50% based on calculations compared to a normal engine. That means efficiency goes up for a petrol engine that is run on biofuel from 28% to somewhere between 45 to 57. On the side, you see a normal engine with a cylinder head and a crankshaft. And then you see a green and a yellow circle. The green and yellow circle depict the size of our engine for the same power, no, for the same displacement, to be correct, for the same displacement in comparison to a normal engine. For the same displacement, we do have twice the power. Why? Because we don't have a 4 or 2 stroke, we have a 1 stroke, which means we have 1 explosion for every single turn, which for the same speed of the engine gives you immediately twice the power. Now, because of the efficiency, we also have half the waste. And importantly, we have the possibility to use all types of fuel. We can use petrol, diesel, LNG, CNG, LPG, biogas, and also hydrogen or ammonia. Now, let's come back to the name, because you may ask, what is this funny name about? And is it all fake news that Dr. Cropp says he has an engine that can do more power output, since so many people have tried and are still trying? And it's correct. People have tried and some have good engines and they are slightly better than before. The reason that I was lucky enough to find something else is because I don't look at an engine simply as a mechanical engineer. I'm not a mechanic, I'm a chemical engineer. So I look at it as a reciprocating batch reactor. You put chemical in, you put chemical energy in there, you perform a reaction and you want energy to come out. And how many percent is what counts the most. So looking at what is all wrong or not that good in existing engines, we have redesigned this process. So when we call this engine HyperX PTT, we mean hyper expansion. That means your normal engine compresses 1 to 10 for petrol, 1 to 20 for diesel. And then you have an explosion and you decompress in the same way. You can't change that, but we can. So we compress 1 to 10, but we decompress 1 to 40. Now, what does that mean? It means when we open the exhaust, there is no more pressure left because the pressure has all been converted into motion, which means more energy is available at the crankshaft to be converted into anything else. At the same time, you don't need an exhaust or a silencer anymore because there is no energy left to make noise. So based on that, already the engine becomes cheaper. Now, the other thing is, we like turbines, yes. But turbines have blades which have a space in between them. And when you send the medium into there and you hold the shaft, the medium will still go through. That is also the case if you don't hold the shaft, but you just take power off. It's called bypass loss. If you have a piston engine, it's a positive displacement engine. It's all sealed. So you stop the shaft, nothing goes through. Now what we have here is actually a positive displacement turbine. That means it functions almost like a turbine with almost as little friction as a turbine. But when we hold the shaft, no medium can pass. This alone creates an additional efficiency of 8 to 10%. Okay. No exhaust noise, I already mentioned. All the parts are not required. Now, one more thing. All your engines, they have cooling systems because you don't want your metal to melt away while you're running the engine. But this heat is normally cooled away from the engine in the form of warm air behind your car. In our case, we also use the cooling, but we put it only on the hottest parts and make steam out of it. Now, guess who also did steam and made an engine out of it? That was James Watt. He invented the steam engine. So we are using his principle to create steam and run the engine instead of using fuel. That means we have 1, 2, 3, 4 fuel cycles, and then we have 1 cooling cycle. So if out of 5 cycles, we use 1 with steam, we already save 20%. Now I mentioned the engine is similar to a turbine. It has almost as little wear as a turbine, which also means more power. On top of that, it means you don't have to repair it. It will last longer than a piston engine, which has piston and piston rings rubbing against a cylinder wall, causing power losses and require replacement or refurbishment once in a while. So this engine has less of these issues. it will most likely last up to 2 to 3 times longer without any refurbishment. This saves cost for the operator, it improves reliability, it reduces downtime. Now, I mentioned to you, we can do multi-fuel. You may ask me, how can you change from diesel fuel to petrol or the other way around if you have to change from a spark plug to a glow plug or whatever else? That's a good question. And we don't want to do that. So what we did is we re-engineered the spark system so that we have a spark system with less parts, with a tiny electrode, running on a small, tiny lithium-ion battery, but it's firing not just once, it fires hundreds of times per cycle. And it can ignite any fuel. Why do I say that? If you take your spark plug from the car and put a piece of paper between the electrodes, the spark may go through to the paper, but it won't ignite the paper. But you now look at this. This to you, hopefully, is enough visual proof to believe that we have done something beyond the normal car engineering and that we can ignite any fuel, no matter whether it's diesel, petrol, nitrogen, ammonia or hydrogen. It doesn't matter. This is hot enough to guarantee we ignite it. Okay, some more details here. Because it's a one stroke, we have immediately doubled the power at the same RPM, which means we can build smaller engines for the same type of application. Because of the steam, as well as the hyper expansion, together with the low friction and no bypass loss, we estimate 30 to 50% higher efficiency. In terms of putting this engine into an application, if one cylinder is not enough, the engine is modular, they can be stacked. And I should mention one more thing. We do not need the gearbox anymore. The reason is we can run this engine at 20,000 RPM, but we can control it to have only 2,000 emissions, which means that is exactly what your gearbox does. By reducing your gear, you can run 200 kilometers per hour on your car with 2,000 RPM. And we do the same with our engine by having 20,000 RPM, but only doing 2,000 emissions, which means our fuel consumption is the same as if you had the gearbox. However, the gearbox is almost as expensive as the engine, sometimes even more. The weight is also more, and all these parts and all these costs can be saved. They are not required anymore. So no gearbox required, no exhaust required, no complicated cooling system required. And also the engine with half the size can have the same power. The savings are dramatic. We believe this will be the engine of the future and replace almost any engine that is currently out there. It will take some time, but it will come. One last thing. Everybody is talking about electric engines. Yeah, we like electric engines. And an engine that do combustion work also needs an electric motor, at least a starter. However, seeing the demand, we have put our thoughts together to design an electric motor that is compatible with this engine. So it's also modular, and it can be simply flanged on. Other people's motors also can be flanged on. But in our case, we have designed an electric motor that is similar to Koenigsegg or to Yasa, which is actual magnetic flux. Because of that construction, we can have a pancake type of motor where we add modules to make it larger or smaller, depending on how much power is required. So that way we minimize the size, and because we can avoid using iron or magnets, we also can reduce the price. This is also something very new, and only recently we have concluded the final drawings to get it into place. I would like to leave you with one thing to consider. No matter what we all do, in the end, we earn money also to enjoy. To enjoy, we need to have a better environment with less plastic flying around, with less rubbish. But in order to have a better environment around, we all also first need to have a better thinking from within. Thank you very much.
Yeah, thank you, Dr. Richard Cropp, for an excellent presentation. So, is there any questions from audience to ask Dr. Cropp about his hyper engine or his
Yeah, I've got
questions?
a two-part question, if you don't
Yes.
mind. So yeah, a great presentation. It sounds like you're doing some innovative work. So I'm a diesel fitter by trade. I'm a mechanic. And yeah, I've certainly seen a few engines that can run on various fuels. That's certainly easy enough with 2 and 4 strokes. The thing that I'm confused with is you say it's a single stroke with a high, potentially high compression ratio, but you also say it's like a turbine. So I'm just trying to understand, is it rotary or is it linear in the piston?
That's a good question. I forgot to mention, but that is why I put the drawing in. It should depict rotary, and it is a rotary. However, however, it has no similarity whatsoever with the Wankel.
Sure. Of course. My other question, so to have combustion, you're obviously drawing in oxygen, but you're saying there's no exhaust, no emissions. I'm trying to understand, where does the CO2 go?
Okay, I did not say no emissions. What I said is you have an exhaust in the form of an outlet where the combusted gases are being left out of the engine. But what you don't need anymore is a silencer.
Right.
So you don't need a muffler, you don't need a catalyst. Actually, you don't need a catalyst, partially because 1 stroke means we have a full power stroke for 360 degrees in this engine. And that is enough to give enough time for the same RPM. For the same RPM, it gives you twice the time to do a proper combustion.
Sure.
So that alleviates the need for a catalyst.
Okay. No catalytic converter, no muffler. Yeah, great. Yep. Well done.
Take all the money, go holiday, and enjoy hopefully a greener environment by then.
Well, I wish you well. Good luck.
I wish us all well. We need to do something now.
Yeah, sure.
I see this for the past 20 years, and I still remember in Germany, I lose a piece of paper and people say, hey, you lost something. And then I see nowadays the pictures of a beach where you cannot see the sand anymore because it's all plastic.
Yeah, agreed.
And it makes me it makes me sad and it makes me mad.
Yeah, agreed.
If I could, I would put a machine there and immediately gobble up the plastic so that in the end of the day, there is a few tons of oil that alleviates the need to take it out of the ground.
Yeah, I wish you luck with that. Thank you. Good on you.
Yeah, we all need that. Thank you.
Yeah, sure. Is there any questions? So can we move with the next presentation? One more presentation is left. It's from Syncraft. Mr. Marcel Huber.
Hi, Xavier. Can you hear me now?
Yeah.
Okay, perfect. So I decided to keep my questions about this engine into my presentation because I think that it's a very interesting approach. So I share my screen.
Yeah, you can
Hopefully-
share your screen.
Hopefully it still works, not only
Yes.
should work. When I switch to presentation mode, it should work as well.
It does.
Thanks.
Can see something? Yes.
Okay, so let's make that smaller. Okay, great. So hello, everybody. My name is Marcel Huber. I'm CEO and one of the founders of Syncraft. And what is our idea is to put the reverse idea before the common forward idea. This is more and more shaping our understanding about the future, that we have to understand that bigger, better, faster might be at its peak. And we are there to provide solutions beyond without total decline of everything, but still keeping this negative emission upwards. And so I just introduce you roughly to the agenda, something you have to allow me to tell about our company. Then we have this topic, reversing climate change through biochar. I will share what is our understanding on reversing climate change and that it is possible. Then we talk about our power plants. They also include an engine. About our technology, about our fuel, which is forest residues, and about the biochar, which is biochar is not biochar. We have a special one, an awesome one, but it is not for all usages the perfect one. I think this is quite something getting mature. And then our big call, let's work together. There is no competition. There's just a big task to be done. Yeah, we are still an SME based in Austria, right between the mountains, and 50 employees, and we pursue this mutual goal of reversing climate change. And this is our main tool. The main tool is something that generates heat and power, as we have maybe heard before, and this awesome byproduct biochar. So all three products are done by intention in our systems. So there is no, you can't say, I don't want a heat, I don't want a biochar. You may can say you don't want a power, but this is our core product. So maybe then you have other technologies right and available. Yeah, and our mission is to be understood as a part of a big puzzle. So there is not a single approach that will get us out of this. It's something put together in the right order. And we combine this idea of carbon dioxide removal and bioenergy, and carbon dioxide removal in its best form as we understand it, and best is meant by concentration and meant by efficiency is BCR, which means biochar carbon removal. What about this issue reversing climate change? I mean, sounds quite ridiculous and undoable if we look at current figures, but in truth, it could be quite simple. This is the problem. This is the problem you see here, and this shows the curve of the increased CO2 concentration in the atmosphere. And what you see is these up and downward development of this curve. And what you see inside is that on the northern hemisphere during summer, biomass, and it's only biomass because there's more ocean in the south, in the land-based biomass during summer takes up more CO2 from the atmosphere than we still emit. Yeah? Of course, there might be some difference in warming buildings in wintertime, but the majority is gone to transportation and industry, which doesn't care about outside ambient temperatures. So in fact, nature is doing this reverse mode every summer on the northern hemisphere today. And the only thing is it decays in winter. So if we prevent decaying things, we can do the reverse mode by on the shoulders of nature. And there's a simple approach to stop decaying biomass. It's to carbonize it, because that is done by nature for billions of years. So this is nature forms out of biomass carbon over ages. And the other thing what we do is we do the turbo on that. So we produce permanent stable carbon beside the renewable energy production. And so if we do that consequently and at scale today, we could reverse climate change for sure. But the thing is, what prevents us is we do it not at the speed we need it. And of course, we need all other pieces like direct air capture or bioenergy and carbon capture as well. So there's not only a single task for that as well, but biochar could be the main pillar of reversing climate change. I've heard this already today, so I will just jump through. So if you have this idea of burning or decaying biomass, you have this 100% CO2 again released in the atmosphere. So this is called climate neutral cycle. If you put a climate positive cycle on it, you put it in a plant and you can capture up to 30% in our case. In some pyrolytic only cases, as we have heard, you can increase that maybe up to 40–45%. But only 70% is still released to the atmosphere. So if you do that constantly, that is a 30% more than the natural path is. And if you base it on forest residues, there is no tree cut for that purpose. So you just take these amounts of biomass you don't use for furniture, plyboards, sawmill industry, and whatever. This is what we call a significant share of CO2 captured with any cycle of usage. So what we actually do, I due to the time, I just jump over to this video, but if you want, we have it on a homepage that describes our process in detail. This is what you see here is a 4 megawatt plant, 4 megawatt electric we built in Switzerland. I will show you that afterwards. So the thing is that we highly innovative. We have this decentralized approach, which is crucial, as we have also heard in logistics. It's climate positive with a awesome efficiency. So the total efficiency from fuel on the wet basis is 30% to the generator. So the combustion engines are running at 40% internal efficiency. We have a heat to power ratio of only 1/4. So 1 megawatt of electricity provides only 1.4 megawatts of thermal. We have no residues. We have no dust emissions. You don't need anything to run the process instead of biomass, of course. This is our product range. So our main focus is at the moment at the megawatt level. So big or even bigger is even more beautiful day by day, because we have to fulfill demands of industry today. And these are quite bigger than these normal things. I show you now some references. This is some top-notch plant we have built in Austria. It's a 1 megawatt plant. You've also seen it on the front page. 1 megawatt plant. This is what we have seen before in the video animation. This is a 4 megawatt plant we built in Switzerland, and today this is the biggest carbon dioxide removal plant on a commercial basis up and running. So that's even far bigger than the Orca plant from Climeworks, but as it is only on biochar, it's totally underestimated or not seen accordingly, but I'm sure that will change soon. We have also built a plant in Japan. We have a plant in Italy, and there are many, many more. I just want to give you some ideas of size and locations of these plants. What is the underlying matching in our system? How does the process work? First of all, we have a staged thermochemical conversion process, which is unique on our own system. We have a pyrolysis first that turns the biomass into biocarbon. And then in the second step, we eliminate all these long chain carbon hydrogens. We just burn them, honestly. We turn them into CO2 and water vapor. And then we recombine clean carbon together with CO2 and H2O in form of steam into a syngas, in a very clean syngas that ends in a clean carbon and in the clean gas suitable for high-end gas engines. So in our case, this is the tar elimination, so to speak. We here burn, like in all incineration plants, all these impurities from pyrolysis step, so that we don't end up with something like a wood vinegar or tar. So this is eliminated, and we end up with a clean flame right after the filter, so without any gas treatment, which is quite crucial to run these engines, what we do. Further, there's a high grade on fuel flexibility. It's always about cheap fuel. Cheap fuel is a residue. Cheap fuel on the wood base also contains bark and fines and whatever. So we have a setup of a system developed that can cope with these kinds of fuels, that only operates at 850 degrees, which does not melt the ash content in the biomass, which is quite crucial. What we can't run on is on any kind of agricultural residues. So as soon as there is some virtualizer applied to the fuel, you have this potassium inside, and potassium-rich fuels are a no-go for our setup. Yeah, that's the system. What you see here is a picture of this floating fixed bed. So whenever you think what we do is based on the fluidized bed, it is not. It is a floating fixed bed, and this makes us unique, and this gives us the advantages and USPs we have. We come with an industrial design. We come with these engines that you see the two top brands I would call worldwide on syngas engines. That's on the left side, it's 2G. They would come with the 400 kilowatt plants. On the right side, that's also a Tyrolean company, Jembacher, which is quite famous for high-end gas engines. Yeah, what's the fuel about? As you see, we talk about these residue issues. I give you some key issues. As I said, agricultural residues are not suitable. We are very tolerant towards stones and nails. Someone has turned off his microphone and is not talking. Hello?
Yeah, it's muted now. You can continue.
Okay, thanks. We are very tolerant to stones and nails because of our system, and we can operate on these residues. Then we have this high quality raw material. I by intention call it raw material and not product, because the biochar has many options to go to. you see here 3 totally different applications. We have this feature grade biochar, so we get the feature grade of EBC, for example, for the European biochar certificate. You can also do soil amendments, and what is quite interesting from our perspective and is to go to climate positive or CO2 negative, sorry, concrete. Yeah. So if you put that in industrial context, it's doing awesome things. And there is also a great company. He's doing a lot of investigations, and we're building a lot of things already in the real world based, which is a company called Castocon. You can find this company on one of the next slides as well. What is the biochar like? So I said biochar is not biochar. In our case, it's certifiable. We have very high carbon content, but it's dusty. So it's not chunk-wise. We have a fine dust particles. It's totally free of impurities. So there are no stones and nails from the original biomass in by nature of our process. And it's inertinite. And I have a separate slide for that at the end. Yeah, why it is so valuable in terms of fighting climate change. Kathleen Draper from the IBI in the US calls it shuffable. It is touchable, shuffable CO2 in its highest durable concentration. And that's why it's so easy to make out a carbon sink ecosystem on it, a trustful, understandable, a touchable. So in our case, when the plants produce the biochar, they create these certificates and the biochar, and they sell it to certain dealers, and they then sell it to farmers, to construction companies, and so on. And they sell carbon and the climate service, the negative emission, also do them. And they then can sell the certificate alone to carbon credits dealer, which go to the offsetters. And that ecosystem is today up and running already. So we have certification bodies, we have tracking bodies, which is Carbon Future. We have top-notch associations like the EBI, which framed all this work. Yeah, we have these certificate dealers, and of course the most valuable offsetters dealers, those who buy these carbon credits on the market. My last slide goes to inertinite. So it's always about the biochar, and when we talk about carbon removal and saving the climate, we have to have a carbon storage that works, let's call it forever. I mean, this is quite long, but maybe this is the closest approach. And by means of geoscience, we today know that what we produce is the most stable form of atmospheric CO2 you can think of. And this is high-grade biochar. And if you put it to something where it can't be burned anymore, it's stored and sequestered. And this is the key. The only thing you must not do with it is to burn it, because then, of course, the CO2 is released again. Finally, these are some numbers. So what we have built so far, electric power plant uptime, availability, CO2 tons captured, it's still nothing against the mutual target we have or task we have. But what we call it, it's a beginning. Thank you very much for your attention, and looking forward to all kinds of questions. Thanks.
Yeah, thanks, Huber. So thanks for an excellent presentation. Is there any questions regarding this presentation?
Yes. Are you willing to consider to change your engines?
I just sent you a LinkedIn request. I think we have to talk about these details, yeah, of course, because we have also investigated fuel cells and other thermochemical machines that convert the gas into a more valuable product. And I think this is for sure always open to this discussion to produce more power. Yeah.
Thank you for the consideration. I take it on me. I have to make it happen because we know people or companies like Wärtsilä, they have lots of engines going around and they are all going at a slow rate. Have you?
Oh, for sure.
Have you considered to use your biochar to make nanographene?
I have some back coupling in my loudspeaker.
Yes.
Someone has turned on his microphone as well.
Yeah,
Yeah.
Pasi Ambe, if you would mute yourself.
Yeah, I am Ambe Pascal, a production manager for Biochar. Demio. Please, I have a question. I want to ask, what is your position concerning the thermal energy production for countries like in Africa? Because we here have a lot of energy issues, and then most of the countries are looking forward to convert their biomass into energy sources. What is your openness to partnership with countries like, for example, Nigeria, Kenya, Cameroon, and other countries, please?
Richard, we will come back to your question. I will try to answer this first. The thing is, for at the moment, our power plants are, I call it, it's not easy. It's a complex machine. Also, the engines are top-notch engine. They need a certain infrastructure, just to be honest and frankly about this. Yeah. So actually, we're doing projects in industrialized countries, and for us, it's a big challenge to do this plant ready for the rest of the world. Just as a SME, it has been a big challenge to do a project in Japan as well. So beg your pardon, that at the moment we have limited possibilities. We need a considerable good partner for that. But if we find that, we are open to everything. Yeah. Concerning the heat, yeah, we have to turn it into cold. Yeah, into by absorption heat pump. We can turn easily the heat into cold to cool down buildings and so on. And I think this is one of the most interesting heat utilization for maybe more hot regions than on the northern hemisphere. Maybe also for food processing and something like sawmill industry, they naturally all need industrial heat to do their jobs. So these are, of course, also very good integrated heat customers here in Europe. So I think all in all, it's not that different. Yeah, but of course, utilizing the heat is a bigger challenge in warmer countries than in the north. Yeah.
Please, I still have last question. The maximum capacity, what in terms of capacity of energy production, what is the capacity we intend the lowest to be produced and the highest, please?
What we do is on base of electricity, we do between 400 and 4,000 kilowatt.
Okay, I have a question related to that. Can you give a guideline for the capex involved in doing 400 versus 4,000? And second part of the question, if you go to another country, do you have financing assistance available, or everything has to come from the local partner?
What we have is, as a rule of thumb, you can assume our systems cost roughly 5,000 euro per kilowatt electric installed. Yeah? That is a almost turnkey figure, but of course you have to think about surrounding issues change all the time. Yeah? So this is a rough number that works between 400 and 4,000. So in our case, the economics of scale at the moment is not boosting or turning everything upside down. So the 4 megawatt plant is in the same digit than the smallest one. Now, that is our modular approach. Yeah? If we go to new countries that are not in Europe or even a bit remote, we have to have a strong partner that does these projects together with us, and we're not going for finance in other countries, and this is not in our sphere of capacity at the moment. Just to be honest, I mean, we are 50 people. You have to have partners, but that is our intention. Like we did in Japan, you have to find proper partners that do the complementary works. In some countries, we are not allowed to install, so we just can send supervision. We can then send a set of Lego pieces, and that our supervisors will put together with the plant. And we successfully did that in Japan as well, but during COVID, by the way, in Japan. This was quite an issue, but yeah, almost everything you can do with an incredible team. So
yeah, I was mentioning this because we have one German partner. They want to come here, and they say up to 70% can be financed with a European bank, but the remaining 30% the local partner has to provide, which is quite a good deal. But I was just wondering whether you have something similar in the pipeline.
yeah, in Germany, they are very, or quite, let's call it aggressive in terms of the KfW has some more instruments than we have in Austria. But there are also possibilities, of course. So we also have these, but it depends on the country, on the boundary conditions. I mean, foreign financing is something which is not my key competence, just to be simple about that.
Okay.
Yeah, thank you, Huber. I have one question for you. So, carbon credits, what are the total number of carbon credits created till now from Syncraft? Is there any rough number?
Now we have this on our last slide. We have this 123,000 tons.
All are sold, all are sold, or
captured. No. Just to be honest, this is the captured amount. So what we do is, and you have to think about, this is quite a big amount. This is not a. It's on the other side. It's today. It's roughly 50k tons of biochar produced. That's the corresponding number of raw material. So I would say this has to grow mature. You can assume that half of this amount has been sold as a carbon credit, but the other thing is used for different applications. Just to be clear, one of the applications is also we're doing barbecue briquettes on a very renewable, sustainable basis, which is one part. You've seen Alpenkohle CO2; they are doing this great job. So you find our biochar also in this form. We call it CCU because if you can claim the CO2 into the cola bubble, is also CCU. That means carbon capture and utilization. So making barbecue briquettes is the same. Yeah, but it's not carbon capture and storage. So consider half of our 120k sequestered, the other half is utilized.
Yeah, thank you.
we have to go for a gigaton. Huh? This is the thing with the many zeros, which is incredible. Huh?
So is there any other questions? There are some questions in chat, so I will ask you quickly so that if you can answer. Same capacity of the nations. Are you looking for a dealer or representative to non-industrialized countries?
Pardon?
Are you looking for a dealer or representative for non-industrialized countries?
It depends. I mean, it's not only a dealership; it's complex. So it's a lot of EPC. We need an EPC financing, all the things we are not capable for. So it's you have to build up service. But yes, we are not looking by really searching, but I think it's about networking and things like that. Yeah. But we are very open to everything.
Yes.
Yeah?
And another question is there your project methodologies approved under VCS, voluntary carbon schemes, or do you have MRV validations for MRV validations? Verification methodologies, which methodologies you are following? Maybe
we are following the EBC Sync standards, which is implied by carbon standards. But it's also prolonged to Vera and Puro, so that there is no. I think the key is the tracking. The tracking, which is more or less done in all our cases by Carbon Future. It's about the transparency. Where is the biochar produced? How is it certified? And to whom it is sold, and all these steps, they have to be considered. So because it's all about trust, you buy a ton of CO2 and you trust that it is sequestered. And so transparency and this tracking is quite crucial, because if you produce a ton of biochar, you can't issue a credit. Because the next one buys it, and if it turns into barbecue, then it's bullshitting or green. It's not even greenwashing. That's a big issue. So you have to track the production and the storage.
Sorry, Marcel. Great presentation, by the way. Yeah, we do carbon credits from our biochar, and I also have worked with Pyrocal for them to generate carbon credits as well. That's another Australian company who do gasification. So there is, biochar can be a carbon credit generator. We've had Puro Earth and Vera come and look at these machines, and they're very excited. Our emissions we've got under their strict regulated. So it can be done, and that really sort of changes the game, because not only can the person making the biochar earn money from the biochar itself, but as long as it's, you have to certify that it's not being reburned. You're quite right, but there are certain stipulations, but if you can guarantee that it is going in the ground to grow food and that sort of thing, which is what my customers all do, then you can actually generate carbon credits. We're doing it.
I mean, in Europe, this regulation, which is called CRCF, that's climate carbon removal and carbon financing, that will define on a legal body level the methodologies of carbon removal. That will come out next year, and I think this will end these open market certification things. So because it will define things on a huge, gigantic level, and then everyone will be safe. Then a CO2 ton is defined what you have to do, and then we are on a more confident, solid ground with these carbon credits. And then they also
Yeah.
can be part of the ETS system, of course.
Sure. Yeah. No, we definitely have to guarantee, and it's third-party verified, that as long as the biochar is weighed and tagged and is signed off that it is going into the ground. I've had to do that a couple of times myself, but it's also being done. We're doing some work in Africa on that very ground at the moment. So yeah, it's a good thing for the industry. It really helps the industry a lot. And as we know, it is very carbon negative. When it's done in a airtight pyrolysis system, you might have seen some of my pictures. Every leaf is still there. It's unprocessed. So you see every vein in the leaf. So it's the way to maximize the char, which means you've got the most amount of carbon preserved. So yeah, it's a game changer.
Thanks.
Yeah, thanks for all the questions and presentations. So I think we can close the webinar today for now.
Thank you. Have a nice day.
Yeah.
Bye.
Thanks. Great presentation.
Yeah, thanks all. Thanks everyone to join this webinar. Thank you. Have a nice day.